In this lesson, we're going to continue our examination of rotational trigonometry. In particular, we're going to start looking at how we can get exact values of angles without using a calculator. To do this, we're going to keep our focus kind of narrow. We're going to look at things we can find using the 30 degree, 45 degree, 60 degree, or any combination of those kind of angles. So for example, 120 degrees we can do because it's 430s, or 315, or 180, or anything that's a combination of 30, 45, or 60. To do that, we need some tools to start. The first tool we're going to start off with is the unit square. The unit square means the easiest possible square we can think of. That is, one that has a side measurement of 1. If we take that side measurement of 1 and then we divide it diagonally, we form ourselves a right triangle, kind of like we're going to need for when we do rotational trigonometry. You can imagine putting this on the axes. Okay. What's nice about this triangle is, well, if one corner is a 90, the other two have to be 45s because it's an isosceles triangle. And the third side, the radius side, if you will, can be found by doing 1 squared plus 1 squared equals r squared. Or in other words, 2 is r squared, and r is root 2. That's kind of handy for us. So we know we have a triangle. We call this the 45, 90, 45 triangle, which has sides of 1, 1, and root 2. The second big idea is to design an equilateral triangle. Now this time we're going to use a side length of 2. That way we can divide it in half, okay, this way, and create a 30, 60, 90 triangle, as you can see here. Again, if we divide it in half, the bottom will become a 1. The radius is still 2, the r part. Now we need to get this other side here. We'll call this y, because that's the direction it is now. And we can do 1 squared plus y squared equals 2 squared. In other words, y squared is 2 squared minus 1 squared, or y squared is 4 minus 1, y squared is 3, so y is root 3. And we've got ourselves, again, the sides of a triangle, 1, 2, and root 3. I am going to get you guys to memorize these down the road, our two special triangles, 30, 60, 90, 45, 90, 45, and you have to know the sides. An easy way of remembering it, that root 3 always goes beside the 30. Okay? 2's are always on our hypotenuses. One time it's a regular 2, one time it's a root 2. And the 30, 60, 90 has a 1, a 2, and a 3 in it. Okay, so we're going to try some things. So we want to find the exact values of these angles. So using rotational trigonometry, here's 0, here's 90. We're going to go counterclockwise, so sine 60. Okay. My 60 has to go here. I need to rotate counterclockwise. If that's 60, that's one of my special triangles, because I need a 90, I have a 30. Beside the 30, always root 3. Hypotenuse is always a 2. My third side needs to be a 1 to get a 1, 2, 3 in here. If you think about Sir Sixertex, I can find the sine of 60 by using the y direction over the r direction. And so I can say that sine 60 equals root 3 over 2. And if I try my calculator, I get the same answer as I do with this exact value. If we do tan 60, I don't need to redraw it because I already have the parts and pieces I need. I just have to figure out which ratio to use. Tan is ticks, so root 3 over 1, or we can just call it root 3. Secant 45. So I'm going to need a new diagram this time. All right, so 0, 90, 45 would be right in the middle. And it's rotational, so I have to go this way around. Notice I'm always making triangles. Okay. If they're both 45s, that means it has to be a 1, and a root 2. Secant. Secant is the opposite of cos. So according to Sir Sixertex, I should do x over r for cos. So I should do r over x for secant. So I write down secant 45 equals r over x, or just root 2. If we type cotangent, cotangent 45 is the opposite of tan. Tan is text, so cotangent is x over y. In this case, 1 over 1, or just 1. Okay, and those are ones I can't do with my calculator very easily, so it's kind of nice to be able to do this rotational exact value by using my special triangles. Okay, so these ideas can be extended past 90. All the 4 examples we just did are angles with less than 90. If we go past 90, we have to apply the same ideas, but there's some small little changes we have to worry about. Okay. When we go past 90, the angle that we're measuring always starts at 0, it rotates around. We call that the principal angle. But like yesterday, I actually need to use the angle inside the triangle, the related acute angle, to actually make my triangle. Okay, so there's a relationship here between, if I knew this was 120, well then this has to be 60, because they always add up to 180 degrees. It's a straight line. The angle that's inside the triangle, the acute angle, is going to give us our ratio, but it's always related to the principal angle, the one we actually want. And so a couple of steps here for you, if you will. 5 of them. And we're going to draw the terminal arm in the correct position. So it means you have to rotate counterclockwise as far as you need to go. You're going to make your triangle with the x-axis always, right? So make sure we have a triangle. We're going to use our acute angle inside the triangle. That would be the one down the corner. We're going to label the sides and angles. There's our special triangles. And then we're going to use for Sixer-Tex to actually find our answer. Okay, so we'll try some just to show you how this works. So cos of 315. So 0, 90, 180, 270. 315 has to be down here. 315 is all the way around to there. If that's 315, and I make my triangle with the x-axis, how much is left inside? Well, I know a complete circle is 360, so this has to be 45 inside. If that's 45, that's 90, that's 45. It's a special triangle, 1, 1, and root 2. Here's one of the little tricks though. When we go down the y-axis, this direction, things become negative. So sometimes we're going to get negative signs in here. X can be negative, Y can be negative, R cannot. R is the radius. Okay, back to Sir Sixer-Tex. Cos is X over R, so 1 over root 2. Oh, I see a radical on the bottom. We're going to have to rationalize. Root 2 over root 2. So we're going to end up with an answer of root 2 over 2. Okay, that's it. That's all we want to do. Stop there. I'll try the next one. Cosecant 240. So 240, 0, 90, 180, 270. Oh, 240 is between them. Make it with the x-axis. I want 240 to go all the way around to here. I know up to the line is 180, so I've gone a little bit past the line. How much? 60 past the line. So it takes this 30. Beside the 30 has to be a root 3. Hypotenuse has to be a 2. Other one's got to be a 1. 3, 2, 1. I look for negatives. I've gone to the left, so my x is negative. I've gone down, so my y is negative. Now I think about Sir Sixer-Tex. Cosecant matches with sine, opposite of sine. Sine is y over r. So our answer is going to be r over y. In this case, 2 over root 3. But I have to, negative root 3. So I have to rationalize. Got radicals on the bottom. So I end up with an answer of what's right down below here. Cosecant 240 equals 2 root 3 over 3. There has to be a negative sign here. Your choice where you put it, top, bottom, or in front. I'll put it up there. Okay. Try the last one. Tan of 150. Draw my diagram. 0, 90, 180. 150's got to be in there with the x-axis. That's 150. So inside's got to be 30 to make 180. Beside 30 is a root 3. Hypotenuse is 2. 3, 2, 1. Any negatives? Yeah. I went to the left. Tan is ticks, y over x. So 1 over root 3, and it's negative. We got to rationalize. So I can say the tan of 150 is negative root 3 over 3. Okay. We can also do angles greater than 360. The only difference is that we have to rotate more than once. We go round and round. So if I come across secant 420, I can basically say that's the same thing as, if I subtract 360, secant of 60. Because all we've done is gone around and start over again. So 60 is there. Okay? 420 is all the way round and round and round. So triangle with the x-axis, 60, 30, 90, 3 and 30 go together. 3, 2, 1. Secant is the opposite of cos. This should be r over x. Secant 420. R is 2, x is 1, or just 2. Okay, secant of 690. Go round and round. So 360 gets us to the beginning. How much past that? This is the same as 330. Go round and around. There's a 90, 180, 270, 360. Start all over again, right? So 330 would be down here. This whole thing is 690. But really, I've gone 330 past. If I triangle, I'm going to have to 30 inside. 30, 60, 90. 30 goes with root 3, 2, 1. I went down, so it's a negative. Sine is y over r. Done. And then cotangent, 495 is the same as cotangent. Subtract 360 again, 135. To draw it, 135 would be here, between 90 and 180. If it's 135 on the outside, the inside's got to be 45. Which makes that 45, 1 root 2. We went to the left, so it's negative. Cotangent is the opposite of tangent. Tangent is tix, tyx, so ours is x over y, negative 1 over 1, or just negative 1. And these are our special triangles. These are how we can find exact values. Okay. Last idea, what happens if we have negative angles? Well, in that case, we have to work backwards, clockwise. So if I get cos negative 135, I have 0, that's like negative 90, negative 180, negative 270. We're going backwards now. So 135 would be between these two. We've gone this way, which leaves me 45 inside the triangle. 1 root 2. I went left and down, so I have 2 negatives. Cos is x over r, so negative 1 over root 2. We'll rationalize. I went up with negative root 2 over 2. That's 1 cosecant, negative 240. So going backwards, 0, negative 90, negative 180, negative 270. Oh, there's where the 240 is. X-axis. So I want to go all the way around to here. That's 240, which means I've gone past 180 degrees by 60. So 60, 30, root 3 and 30, 3, 2, 1. I got a negative to the left. Cosecant, opposite of sine. Sine is y over r. So ours is r over y. Rationalize, and we'll end up with 2 root 3 over 3. Okay, once you get the hang of it, they go really fast. As you can see, I'm doing it fairly quickly now. But you got to know Sir Sixerticks, you got to know your special triangles, and you got to think about negatives. That's only 3 things you have to really worry about. Okay. There are a couple special cases that don't fall into these nice, easier ones. Okay. The things that fall on the axes are special cases because you can't make triangles anymore. So if you come across something that falls on an axis, like 0, 90, 180, 270, 360, what you do instead is you make yourself a little circle. And what we're going to do for a circle is make the easiest possible circle. That is one with a radius of 1. Okay, so I just move this down for a second here. Oops, missed one. Okay, so if I make a circle of 1, Okay? Every point has a radius of 1, which makes this point the coordinates of 1, 0, and this one the coordinates of negative 1, 0. This one the coordinates of 0, 1, and this one the coordinates of 0, negative 1. Then all I have to do is think about Sir Sixer-Tix again. Sir Sixer-Tix. If I want to find the cos of 90, 90 would be right here, 90. Cos of 90, x over r, well, point is made up of an x and a y, and I know r is 1. So cos 90 would be 0 over 1, or just 0. If I wanted to do tan 270, 270 is down here at the bottom. There's my x, there's my y. R is still 1. So tan will be y over x. You can't divide by 0, so we actually call that undefined. You can't find the tan of 270. If you try in your calculator, you'll see that, and it'll say error. And then the last one, secant of 0. Here's 0. Here's x and y. Secant is the opposite of cos. So we want, instead of x over r, r over x, and we're done. Okay, so we like the special ones actually. They're actually probably faster than doing special triangles. Just think of a circle and assign coordinates and a radius of 1. Okay, last bit. Let's do some algebraic operations with these things. So I want to find the exact value of each trig expression. So we have math going on between trigonometric expressions now. We're going to approach this in the same way though. We're going to make little pictures. So I need a 60, 30, root 3, 2, 1. I also see a 30 in this question, so I'm going to need a second triangle. 30, root 3, 60, 3, 2, 1. Now I can do the math. What is the sine of 60? So according to this triangle, that's y over r. A cos 30 needs this triangle, which is x over r. I put brackets here to signify they're multiplying, because when I have two things written beside each other, that means multiplying. We'll do the next one, sine 30. Sine 30 would be from this triangle, so 1/2. And cos 60 from the other triangle, also 1/2. So I've taken my trigonometric expressions and I turn them into math now. We can multiply. Root 3 times root 3 is just 3. 2 times 2 is 4. 1/2 times 1/2 is 1/4. And 3/4 plus 1/4 makes 1. So turn the trigonometric expression into numbers. And try the last one. 2 cotangent 60 squared. So the 2 is 2. Cotangent 60 is going to come out of this triangle. It has a 60 in the bottom corner. Cotangent is the opposite of tangent. Tangent is tix. So instead of y over x, we want x over y. So I'm going to get 1 over root 3, and then I need to square all of this. I'm going to follow BEDMAS. I'm not going to rationalize yet. I'm going to follow BEDMAS, see if it rationalizes itself. Okay, fractions straight across. So 2 over root 3 squared. 2 squared makes 4. Root 3 squared makes just 3. So I get an answer of 4/3. And I believe that takes us to the end of that lesson. Lots and lots of parts and pieces in there. And we're going to try a few more practice questions. Once you get the hang of the special angles, they go really fast. Okay. Regular ones bigger than 360, ones that are negatives, ones that are special, and then how we can do a little bit of operations with them.